Hi guys, it's Mrs. Tucker. Okay, yesterday we were talking about mean, median, and mode, which are all considered measures of central tendency. What that means is if I have a data set, what number am I going to use to accurately describe that entire data set? Which number is in the middle that best describes it? Range is always thrown in there, but range is not a measure of central tendency. It's a measure of how spread out your data is. So I want to talk more about that today. We call that measures of variation. Here is your vocabulary for this lesson. There's a lot of vocabulary in this lesson. Okay, so we're going to start here. Blank are used to describe the distribution of the data. So that's going to be measures of variation. Measures of variation are used to describe the distribution or the spread of your data set. Blank are the values that divide the data into 4 equal parts. That's called quartiles. Quartile sounds like quarters, and there's 4 quarters in a dollar. So quartiles are the values that divide that data into 4 equal parts. Next it says the median of the lower half of the data set is some people call it the first quartile. I call it, and I think the book calls it, the lower quartile. And we'll use the abbreviation LQ for lower quartile. Okay, the median of the upper half of the set of data is called the third quartile. Some people call it the upper quartile, and that's what I call it, upper quartile, abbreviated UQ. The range of the middle half of the set of data is called the interquartile range. We're going to abbreviate that IQR. And I also want you to add this to your notes. To get your interquartile range, if they ask you for the interquartile range, that's going to be the number that you get for your upper quartile, subtract the number that you get for your lower quartile. Okay? Then down here it says, and you know what? Let me add something in here real quick, because they left out, you guys can see there's the first quartile and there's the third quartile. Well, where's the second quartile? They leave out the second quartile because we use another name for the second quartile. So let's write this in. Second quartile has another name that we always use. It's called the median. Okay? All right, and then we left this one out. The data that are more than 1.5 times the interquartile range from the upper or lower quartiles are called outliers. They're outliers. This is like the technical definition of what an outlier is. Sometimes I agree with it and sometimes I don't. All right? If you need to pause this video, you can. I'm going to use the data set at the bottom of this page to show you how this all works. And I'm going to do that in the next video. See you in video 2. Measures of variation, video 2. Okay, now that we've got our vocabulary down, let's see how we use all of this. Let's scroll down to here. It says find the measures of variation for the data in the table. All right, the first step, write this down. Step 1, you need to order your data from least to greatest. Let's do that first. Okay, I've just ordered all that data from least to greatest, and if you look at this chart, it's already ordered from least to greatest. I just copied it all up here. All right. Step number 2. After you've ordered your data from least to greatest, we're going to find the second quartile. Of course, we call it the median. So let's find our median. And you guys know how to find a median. I'm going to cross off the 2 low ones. I'm going to cross off the 2 high ones. Cross off the next 2 low ones. Cross off the next 2 high ones. We've got 2 numbers in the middle here. We've got to find the number that's right in between those 2. We're going to add those together and divide by 2. Okay, so I added these 2 numbers together right here, and I divided by 2, and our median, oops, I wanted to make that red. Let me change that. Didn't quite get red. Here's our median. Our median turns out to be 95.75. Okay? Step number 3. Let's find our lower quartile. Lower quartile is the median of the lower half of the data. Okay, so let me grab a highlighter here. The median is midpoint. You don't include the median in the lower half. So all of these numbers here represent the lower half of the data. So we need to find the median of the lower half. So let's do that. Let's cross off the 2 lows. Let's cross off the 2 highs. The number right here in the middle, that's our lower quartile. LQ, lower quartile. So our lower quartile is 91.6. Step number 4. We're going to find our upper quartile, also known as the third quartile. Okay? We're going to do the same thing. Here is the upper half of the data, and the upper half of the data does not include the median. So we're going to go through and we're going to find the median of the upper half of the data. Cross off the 2 highs, the 2 lows, cross off the 2 highs. This number right here is your upper quartile. So my upper quartile here is 101.1. All right? We're going to be using these 3 numbers and our low number here and our high number here tomorrow when we make box and whisker plots. Okay? Now let me do one more step. That technical definition of an outlier, let me go ahead and add that in there because your worksheet has this on it. So let's do step 5. Oh, step 5, you got to find your interquartile range. I forgot that. My interquartile range is the upper quartile, subtract the lower quartile, which is 101.1, subtract 91.6, and you get 9.5. That's your interquartile range. Let me show you a visual of what interquartile range is. Interquartile range extends from your upper quartile down to your lower quartile, and it represents the middle half of your data. So that range represents all of this in here. So that's a spread of 9.5. What I've just highlighted in purple is considered your interquartile range, or the middle half of your data. Okay, I'll see you in video 3. Measures of variation video number 3. This should be our last video. Okay, step number 6. Let's do that technical definition of an outlier. Up there in our notes it said you're going to take 1.5 times your interquartile range. Okay, we're going to do that first. So we're going to take 1.5 and multiply it by 9.5, and we get 14.25. Okay, 14.25. What you do next is you're going to add 14.25 to your upper quartile, and you're also going to subtract that 14.25 from your lower quartile. Okay, when we do that, when I take this upper quartile and add the 14.25, you get 115.35. Let me move that out of the way. 115.25. When you take your lower quartile and subtract 14.25, you get 77. Let me write it over here. You get 77.35. Okay? By technical definition, this is an accurate number for the low end of this range of data, and this would be an accurate number for the high end for this range of data. So if your low number is between this number and this number, then it's okay, it's not an outlier. And if your high number falls between this number and this number, it's okay, and it's not considered an outlier either. But let's say we had 120 in our data set. By the technical definition, 120 would be an outlier. If we had, say, 80 in our data set, by the technical definition, that would be an outlier also. Okay? So on today's homework, you're going to be doing the exact same thing that you just did here. Just follow the steps. Good luck, guys.